Good morning to everyone. I am Sweta from GMRP Gajwel. In this video lesson, I am going to discuss about the block diagram of fixed microwave link, that is in a microwave communication and TV 4th semester. So now I am turn off my camera and start the topic. So on completion of this topic, the student will able to learn about the basics of microwave link and types of microwave link and block diagram of fixed microwave link and description of the each block and advantages and disadvantages of microwave link. So first of all, we will learn the basics of microwave link. So microwave link is nothing but it is a communication system. Microwave link is a communication system and is used to transmit the information between the two fixed locations on the earth. Okay, so microwave link is a communication system and is used to transmit the information between the two fixed locations on the earth. Okay, microwave links will carry the cellular telephone calls between the cell sites. Okay, next, internet service providers can also use these microwave links to provide a high speed internet access without need of the cable connection. So without need of the cable connection, even internet service providers also can use this microwave link. Okay, so microwave link is a communication system and is used to transmit the information between the two fixed locations on the earth, and it is used to carry the cellular telephone calls between the sites, and also it provides the internet service providers also use this microwave link to provide a high speed internet access without the use of cable connections. And also telephone companies also transmit the calls between the switching centers over the microwave links. Okay, so this is the basic structure of the microwave link. It consists of a transmitter, receiver. Okay, so for transmitting antenna, here it is a receiving antenna. So this is the basic structure of the microwave link. Okay, so types of microwave links, we have two types of microwave links, that is terrestrial microwave link, that is a fixed microwave link. One more is satellite microwave link. Okay, so in terrestrial or fixed microwave link, it is a point to point link between the two microwave stations on the earth. One more is satellite microwave link. It is a link that makes use of the satellite, means by using of the satellite the link will be established, that is a satellite microwave link. So first one is a terrestrial or fixed microwave link. It is a point to point between the two microwave stations on the earth. Okay, so first one is a terrestrial microwave link. So once see here we have a 2 points. So by using these 2 points the communication will be established, that is a terrestrial microwave link or fixed microwave link. Okay, so between the two microwave stations, so here once see here between the two microwave stations the communication will be established here. Okay, So next one is a satellite microwave link. So satellite microwave link is here. So by using satellite, the communication will establish. Then we call it as a satellite microwave link. So it is a link that makes use of the satellite. That means by using a satellite, if the communication will establishes, then we call it as a satellite microwave link. Okay. So okay, next one is a block diagram of microwave link. So the block diagram of microwave link consists of a transmitting antenna, receiving antenna, and in between repeater we have. So microwave link mainly it consists of a microwave transmitter, microwave receiver, and microwave repeater. Okay, so if the distance between the transmitter and receiver exceeds the 50 kilometers, so why we use repeaters here? We have to regenerate the signal, we have to use the repeater. Okay, for boosting the signal or for regenerating the signal, here we are using a repeater. By using this repeater, the signal will be boost. Okay, so here the distance between the two devices, that means transmitter and receivers, if exceeds 50 kilometers, then we use the microwave repeater. Okay, so the block diagram of microwave link consists of a transmitter, receiver, and repeater. Once see here, the block diagram of microwave link consists of a transmitter, repeater, and receiver. Okay, so when we use the repeater, the two devices, that means transmitter and receiver, will exceed the distance 50 kilometers, then we use the microwave repeater. Okay, so next one is a, in this first of all we will discuss about what is a microwave transmitter and microwave receiver and repeater. So again we have a microwave transmitter. So in microwave transmitter we have modulator block, IF amplifier, mixer, modulator, IF amplifier, mixer, power amplifier, and in mixer we have a microwave oscillator. So first of all we will give the input to the modulator as baseband input, and the power amplifier output is given to the antenna. Okay, so once we will detailedly discuss about the transmitter of the microwave antenna, then we go to another topic. So the microwave transmitter will consist of a modulator, IF amplifier, mixer, power amplifier, and transmitting antenna. So you can also check by here. So the microwave transmitter consists of a modulator, okay, IF amplifier, mixer, microwave oscillator, power amplifier, and antenna. Okay, modulator, IF amplifier, mixer, power amplifier, and transmitting antenna. Next, coming to the receiver, we have a antenna, that means receiving antenna, and IF amplifier, mixer, IF amplifier, detector, and local oscillator. So the output of the detector is a baseband output. Okay, so microwave receiver will consist of a receiving antenna, RF amplifier, mixer, IF amplifier, and detector. So microwave repeater, so microwave link repeater. So microwave link repeater or microwave, the block diagram of microwave link repeater or fixed microwave link is, this is a block diagram of the microwave link repeater. So in this we have a directional antenna, circulator, this is from a directional transmitter, receiver protection circuit, receiver mixer, band pass filter, IF amplifier, amplitude limiter, transmitter mixer, band pass filter, power amplifier, band pass filter, mixer, power splitter, shift oscillator, and microwave source. So this is the block diagram of microwave link repeater. So we'll discuss each and every block here. So first of all, antenna. Okay, so here the microwave link will perform the same function as like a copper or coaxial cable or fiber optic cables, but in a different manner by using a point to point microwave transmission between the repeaters. So first of all it receives the transmitted signal. Okay, by using this antenna it receives the transmitted signal from the microwave transmitter and amplifies the signal and then retransmitted. Okay, so first of all we have a antenna. Here the antenna is a two oppositely placed parabolic reflectors with horn antennas are used for higher bandwidth. So here we are using a horn antennas. Okay, so horn antennas for getting a higher bandwidth we are using two horn antennas. Next one is a circulator. Okay, so it provides same antenna can be used for both transmission and reception. So for this purpose we are using a circulator. Next one is a receiver protection circuit. So what is the function of this receiver protection circuit is, it protects the receiver to avoid the damages from the high power transmitter. Next one is a receiver mixer. So receiver mixer is for the purpose of double conversion of the frequency is used to avoid the interference and amplification the quality of the signal. So for this RF signal can be converted into IF and amplified it and reconvert IF into RF. So in general the microwave links are in the order of 4 to 6 gigahertz. Okay, for transmission purpose. So amplification at these frequencies requires microwave amplifiers that costly and difficult to maintain. So therefore the RF signal, that is a 6 gigahertz signal, will be received from the antenna, so is down converted into IF signal. Okay, that is a 70 megahertz signal. So this can be done by using this mixer and local oscillator. Okay, so the total process can be done okay, by using this. So mainly the function of receiver antenna is, it is used to convert the 6 gigahertz signal to 4 gigahertz signal, that is a 70 megahertz IF signal. Next one is a band pass filter. Okay, so it is used to allow a particular band of frequencies, that is it allows only 70 megahertz. It allows only 70 megahertz. Okay, megahertz IF signal, and to eliminate the harmonic distortion. Next one is a IF amplifier and AGC. So it is a low noise amplifier for amplification of the IF signal, that is a 70 megahertz signal, and also maintain the gain within the limits with the help of the automatic gain control. So by using this automatic gain control, it maintains the gain, that is limit. Okay, next one is a amplitude limiter. Okay, so this stage is used to avoid any unwanted amplitude variations and noises. Okay, tarvata transmitter mixer. And so this transmitter mixer is used to convert the IF signal into again RF signal, that means 70 megahertz signal to what 70 megahertz signal to 6 gigahertz signal. Okay, so next one is a band pass filter. Okay, so this will transmitting the frequency is passed through BPF to avoid the harmonics and noises. To avoid the harmonics and noises, we use the transmitted mixer and BPF. Okay, next one is a power amplifier, that is a high power amplifier. So it amplifies the RF signal to required level. It is usually a traveling wave tube. Okay, so here we use a traveling wave tube for amplification purpose. Next one is a microwave source. So that is here we have, it generates high frequencies. That means it is a VHF transmitter crystal oscillator with a varactor multiplexer. In modern systems, magnetron can be used to generate the microwave frequencies and high power. Okay, next one is power splitter. Okay, so the power from the microwave source is applied to this power splitter. It splits the power and deliver to 75% of power to the transmitter mixer and remaining 25% to the mixer stage. Okay, so 75% to transmitter mixer and 25% to this mixer stage. Okay, next we have a mixer shift oscillator and band pass filters. Okay, these three. So this system will provide a high frequency signal, that is 6110 megahertz signal. So the BPF removes, here the BPF will remove the unwanted frequencies from the output of the mixer. So these are the blocks of microwave link repeater. So next we'll discuss in detail again once we'll see. Okay, so already we have discussed, but once we'll check. So antenna. So the antenna is a structure of radiating or receiving electromagnetic power. So here we use horn antenna or dish antenna, that is used for the parabolic reflector antenna, horn or dish antenna. Okay, next here the antenna structure is capable of radiating or receiving the electromagnetic power. Okay, so we'll use horn or dish antenna. Next, circulator is used to connect the transmitter to antenna and used to connect the antenna to receiver. So here there is no direct connection between transmitter and receiver. Okay, next one is receiver protection unit. It is a circuit used for protecting the receiver mixer from the overloads caused by any of other transmissions. Receiver mixer is a low noise device. Schottky barrier diode here we use. Next one is a band pass filter. This the mixer is followed by the band pass filter, which is usually operated at 70 megahertz and having a bandwidth in the 12 megahertz. Here the filter will provide the selectivity of the system. Okay, IF amplifier and AGC. So band pass filter is followed by IF amplifier, which provides the most of the gain of the repeater. So here it is a low noise, ultra linear, very broadband transmitter amplifier. Okay. Next, which consists of a several stages and AGC applied to it. For AGC we will get a perfect gain. Next one is a amplitude limiter. It allows the IF amplifier to prevent the spurious amplitude modulations. That means required amplitude levels will maintain. Next one is a transmitter mixer. So in transmitter mixer we use a varactor diode. Will use. The function is to bring the IF output to the transmitting microwave frequency. Next one is a power splitter. So here the power splitter can split total power into two parts. In that 75% of the power will gives to the transmitter mixer and the remaining 25% of the power will gives to mixer stage. That is rest of the mixer will be gives to shift oscillator. Then one is a microwave source. The microwave source was a Klystron gun oscillator with AFC used in olden days. That means in the year of 1970s. In 1960s they use a Klystron oscillators. So nowadays VHF transistor crystal oscillator with a varactor multipliers are using. Okay. Shift oscillator. The function of the circuit is to ensure that the receiver mixer is fed with a frequency of 70 megahertz. The frequency is higher than the incoming signal. So it has to provide 70 megahertz frequency difference for the IF amplifier. So in this case the shift oscillator will provide a frequency of approximately 70 megahertz. Next one is a mixer. It is used to mixes the output from both power splitter and shift oscillator. The output from the mixer is applied to the band pass filter. So once you see the block diagram, you can easily understand power amplifier. So output of the power amplifier is the output of a link varies depending upon the bandwidth. So the power amplification is necessary. So in general, for power of 0.5 watts or less, power amplifier is not required. Because of low power, there is no need of power amplifier. Okay, and power oscillators may be used in this time. Okay, for low power we use power oscillators. For more power we use power amplifiers. For power between 1 to 5 watts at frequencies not exceeding 6 gigahertz, we use the power amplifier. So here we use mostly used power amplifier is push pull metal, ceramic, desk till triodes or TWLT amplifier we use. So this is a microwave communication tower. So you can also see this is also microwave communication tower. This is a point to point microwave link, that is a 2.4 gigahertz, that means terrestrial microwave link. Next one is a here these are the antennas for microwave communication link. So this is a microwave link indoor version. This is a outdoor version. Coming to the features of microwave links. So number of carriers used in microwave link is at least 4. So they are normally 600 to 2700 channels per carrier. Next, the towers used for microwave links range is height up to about 50 meters, and it requires 200 to 300 watts of DC power. Next, the antennas must be accurately aligned to the next repeater. In difficulty, locations diversity must be used, and it has a wide bandwidth, and transmission quality also high, and reliability between point to point communication also there, and flexibility and improved directivity with the antenna arrays, and easy of communication over different terrestrials, freedom from land acquisition rights, and provides the wireless channels also, and cheaper than the coaxial cables for TV transmission, and easy to design repeaters, and also we can easily maintain, no need of cables also, and transmits both analog and digital microwave signals, and flexibility also there, improved directivity also there, and also reliability between point to point communication also there. Coming to the disadvantages, so bandwidth allocation is extremely limited, and atmosphere effects will be affect the microwave link, and the transmission path needs to be clear, and also RF interference. Coming to the uses, these are used in a point to point communication and connectivity in modern digital IP networks, TV transmissions, used for transmitting the telephone call, data, voice, images, videos, etc. Widely used for connecting in a model digital IP networks, that is 3 Gbps, and also beyond the 3 Gbps also we use these microwave links. Microwave links are used extremely in 2G, 3G and 4G networks. Wireless metropolitan area networks also used for satellite communication. So in this lesson we have discussed about the basics of microwave link and block diagram of microwave link and description of each block in detail, and advantages, disadvantages and uses of microwave links also we have discussed. Okay. So the typical value of IF in microwave link is 70 megahertz. So the microwave signals transmitted towards the sky are transmitted through the ionosphere. Okay. So the frequently asked questions are block diagram of microwave link and explain the function of each block in the microwave link, and draw the block diagram of microwave link repeater and explain the function of each block, and also mention the advantages, disadvantages of and uses of microwave link. Okay. Thank you.